Hello, this is the voiceover version of the Year 8 Zoom lesson that we had today on how to build linear sequences and how to spot them and name them. And so what we'll do is we'll run through what I covered in that lesson just in case you missed it or you want to use it to refer to. Remember, you can pause this at any stage, and that way then you can take your time and do it however you want to. Okay. Couple of starter activities that we've had to go with first. This one up here is where you've got to put in all the different kind of like signs to try and make this work. Let's see if I can do this. Now I went 18 plus 3 is 21, so I thought, oh look, and then you're going to divide by 7, and then obviously it was all going to go pear-shaped, and instead it was divide. So if you divide there, you get 6, and then if you multiply that, you get 42, and then if you take away the 19, you get 23. Woohoo! And I sort of spotted this by working it backwards, rather than working it forwards. I thought 19, that must have been, taken away from something, and then I got the 42, and then I can see it from there. I'll let you play with the rest and have a go at those. But they are just really to get you into the mood. As the same with these, you add these here, so that would be that would be 21. There you go. Okay. Here are some sequences. Then we love patterns. We spot them everywhere. It's one of the things as humans we do. We look for patterns. We look for shapes. We look for sequences. It's why when we look at clouds, we see, flying pigs and airplanes. Well, actually, when we look for clouds, we do see airplanes, but we see shapes in the clouds. It's why some people have a religious experience when they look at some toast and they see an angel or the face of somebody, in the toast. And that has not actually ever happened to me, that bit. But definitely the clouds thing. I always used to have a thing where I used to have a kind of like a blanket, and I'd sometimes look at the blanket and I could see a face in it, and I go, I can see a face in the blanket. But, it was just my imagination. So we love to pick these things up, and we're very, very clever at it. So have a look at these sequences and see if you can spot them. Some of them are very numerical, some of them are a bit silly. That was a pause then for you to, press the pause button so you could work them out. If you didn't, you'll have to rewind so you can use the pause that I just put in for you. Okay, these are the odd numbers: 7, 9, 11. Odd numbers, these are the even ones. Monday, Tuesday, Wednesday, Thursday, Friday. 1, 4, 9, 16. 25. Oh gosh, 36. January, February, March, April, May, June, July. They were the months of the year. And so you can see we're just looking into some patterns. So now what we're going to do is look at some linear patterns. A particular type of pattern, a particular type of sequence that we use an awful lot, particularly where we are in maths at the moment. I love an operations robot, a functions robot, if you like, and I love drawing them and having a little doodle there, a little bit of colouring. So there you've got, I've got two little kind of like function machines. I'm going to drop some numbers in, and I'm going to drop them in as a sequence. So it's going to go 1, then 2, then 3, then 4, then 5, and I'm going to make a noise, and I'm going to run through there, and I'm going to come out here, and then I'm going to get my outputs. Yeah, I love them. But they're not the best way, and they're not the most efficient way of doing this. Otherwise, you end up drawing loads and loads of boxes and loads of boxes. So here we go. I've turned this into a linear sequence. So we've got times by 5 and then add 3. Times by 5 and add 3. 1 times by 5 add 3 gives you 8. 2 times by 5 add 3 gives you 13. 3 times by 5 add 3 gives you 18. Times by 5 add 3, 23, and so on. And what you notice is you get this difference pattern of 5 that goes up in 5, z and that tracks back to this multiplied by 5 here. So we need a better way of writing this, a more efficient way of doing it, and the way to do that is to use this input and make it a variable. And we're going to call it n, and what we do is we do times by 5, n 5 times n, add 3. 5 times the position number, add 3. Here's a different one then. 3 times n, add 4. So position is the first position. 3 times 1 is 3, add 4 is 7. 2, position 2, 2 3s are 6, add 4 is 10. 3 3s are 9, add 4 is 13. Okay, and now we've got a method of building these linear sequences, and we've got a much better way of writing them out than me drawing loads of cool little robots. More efficient, more effective, as much fun. Yep. So here's a few for you to have a go at. See if you can get the first 5 numbers in each of these sequences. I'll give you a moment in order to pause the film. And there's some answers. I'll let you have a moment to tick those or put in your corrections. Remember, use the green pen if you can, so that it stands out and you can see when you've been annotating your work. Draw your attention to this one down here. When you get a chance, 12 minus 3n could be written as minus 3n, add 12. Minus 3 times table, minus 3, minus 6, minus 9, adding and then adding 12 each time. How to spot and name a linear sequence? We've been building them then from the algebra. Now we're going to try and go the other way. We're going to go from the sequence itself and try and go back to its name. Find out what the algebra is that gives us this sequence. This sequence here is linear because it goes down in 3s. The break number, the difference is the same each time. Not down in 3s, goes up in 3s. Oh man, goes up in 3s, plus 3 each time. Sorry about that. And now this one, the break, or we call it a break number, or the difference number is 0. Then it's 1, then it's 1, then it's 2, then it's 3. It's not following the same pattern here. It's not the same number. It's different. And that means it's not linear. This is actually called the Fibonacci sequence. This one here is going down. It's going down in 4s, going down in 4s, going down in 4s, going down in 4s. And so what we can now see is that this is a linear sequence. This one here, oh look, you can tell that the difference each time isn't the same. And in fact, this is a cube number sequence. The cubed numbers. And this one here goes up in 1, goes up in 2, goes up in 2, goes up in 4, goes up in 2. Not a linear sequence. Not a linear sequence. And in fact, these are the prime numbers. All right. Okay, let's take these two linear sequences then and have a look at them a little bit closer. What we can see is that they're going up. This one is going up in 3s. So that means we've got the 3 times table. The 3 times table. 3, 6, 9, 12, 15. And that's where this bit comes here. 3 times n. Whatever we're going up in, that's what we multiply our n by. Whatever this break number is, we multiply by n. Then we've got to think of how do we get from 3 to 5. 3 to 5, we add 2. This one here is going down in 4s. So, or going up in the negative 4 times table. Minus 4, minus 8, minus 12, minus 16. Negative 4 table, negative 4n. So how do we get from negative 4 all the way up to 22? How do we get up all the way up to 22? And that's by adding 26. We add 26, and that will then get us there. If we have a look here at this one, first, second, third, fourth, 4 times minus 4 is minus 16. Add 26 is 10. Boom. Right, let's have a look. Okay, here's some here for you to have a go at. I covered them with these clever boxes because we're going to have a look at the answers on the next sheet. I've left some of the differences in for you to get a sense of what's going on. So have a look. Again, pause the video and see what you can. Here's the answers. Have a little look at them. See if it makes sense. Look for the break number. Look for what what it's going up in. What is this this core to this? What times table are we dealing with? Are we dealing with the 6 times table here, the 5 times table here, the 7 times table, the -4 times table, the 2 times table, and the -1.25 times table. Just because they start getting hard or strange doesn't mean you can't keep the same approach, the same methodology to get the answer. All right, I'll pause it, check it. And this is a bit of fun, just to finish off, a kind of like little puzzle, just to put in at the end. I was going to use it as the starter, but we didn't sort of get around to it, so I've left it there just for your amusement. So that was pretty much what we covered in the lesson. Oh, I've just thrown everything on the floor. And so, excuse me for a second. That's what we covered in the lesson, and so hopefully if you missed it or you wanted to see it through, that makes sense for you. See you next time. That was my ruler. I dropped my ruler.